Hi, welcome again. Now, we all know that the main objective of irrigation is to make sure that crop root zone is always maintained at field capacity. That is the main objective of irrigation. Now, if you want to design any irrigation system, the first thing that you need to know is what amount of water required for a crop root zone to be maintained at field capacity. Now, this is the point where the concept of crop water requirement and crop evapotranspiration sets in. Because if you want to know the amount of water required to replenish root zone into field capacity, you must conduct crop water requirement analysis. Now, there are several ways that you can go around this, but the simplest one is by using softwares like CROPWAT Software. Of course, in conjunction with another software which is known as CLIMWAT Software. Okay, so in this tutorial, we are going to learn how to calculate crop water requirement or how to estimate crop evapotranspiration by using CROPWAT 8.0 software. That being said, as usual, I'll see you in the next part of the video. Okay, let's get started. Now, this is the window, or this is the CROPWAT software, but remember, before we proceed, I'd like to point this out. We need two software here. Okay, so the first one is CROPWAT and the second one is CLIMWAT. So if you don't have them, just go to Google or whatever search engine that you are using, then just write CROPWAT download, then the first link, just click download and install. Again, for CLIMWAT, again, just go to Google or whatever search engine that you are using. The first link, then type CLIMWAT model or CLIMWAT download. The first link, just click it and download. Okay, so if you have them installed on your laptop or PC, for CROPWAT, this is the window that you are going to have. Remember, this is the menu bar, and again, this is a toolbar. So on the left, these are the options that we are going to deal with. Okay, so by starting, we have climate or ETO, then we have rainfall, we have crops, we have soil, crop water requirement, we have schedule, again we have crop patterns and scheme. So we are going to touch one by one and also to see what we can get out of them. So by starting, we will start with this first option, which is climate or ETO. So let me click. Now, this is the window that's going to pop up. Now from here, you are supposed to insert your climatic data. So from temperature, make sure you insert temperature, humidity, wind, and sun hour data. Now there are two options that you can use to get this data. So the first one is by using local weather station. So if you have a local weather station near you, you can just go and acquire the data, then insert them here. Remember, it should be long-term data, at least 10 years up to 30 years data. So the second option is by using CLIMWAT. So as I said, this is the software that we are going to use. Okay, so this is another software that you can use to acquire climatic data. Okay, so from here, remember, I don't have any local data. So what I'm going to do is to make sure that I acquire data from CLIMWAT. So from CLIMWAT, just open. So if you installed it already, just click open. This is the window that is going to show up. Now from here, you can select country. So for me, I'll go with Tanzania. So from Tanzania, actually there are two options. You can even choose target coordinates, or you can choose a country. So for me, the best option is to use country. Now if you selected your country, you have again two options. So the first one is to display all stations within selected country, and the other one is to display stations within and around selected country. So for me, I'll just go with this one. You can even choose this one, they're just the same. So for me, I will go with this. Then I'll double click. So this is going to show up. Now from here, this is a country. Now my targeted area is in this area. Let me click this. Of course, you can see here, or you can even go and select in this list here. So for me, I'll just go with Morogoro. Let me find Morogoro, this one. Okay, so it is this one. So if you click it here, it will display here, or even you click here, then it will show you from here. So for me, I'll just go with Morogoro. Okay, so for now, I assume that my farm or my scheme is in this region. Okay, so I'll just select this. Now from here, what we need is to export this weather station from this station. So from here, I'll just select export selected station or stations. Okay, so this is the window that we end up with. So you can select the file that you want to save your weather or your station. So for me, I'll just select my this folder D, then click export. Okay, click export. Okay, so one station exported. Okay, so from here, I'll just close or minimize, whatever. Okay, now this is my data. Okay, Morogoro. As you can see here, we have two files. So the first file is for climatic data and the other one is for weather data. Okay, that is very important. Now, you can even use them from here. So for me, I just prefer to do this. Let me select, then go to C. Okay, let me go to C and select hidden file. Okay, and select program data, select CROPWAT. Okay, data. Then I'll select climate and paste them. Okay, so I need only to have pen here, and let me cut this with .cli and put it in Rainfall. But remember, you don't have to do this. The most important thing that you need to do is to make sure that you put them in the folder that you can access them. That is very important. You don't need to go through this process. So for me, I am done. Remember, Morogoro pen and this one, Morogoro CLI. I am done. So from here, already I have my climatic data from CLIMWAT. Now what I need to do is to make sure that I import my data from the folders that I saved them. Now from here, let me click open. As you can see here, I have my file here. Just remember, in whatever folder that you save them, just go from here and select it. So from here, so if you saved it in the desktop, just go click desktop, then you will find your files from there. So for me, this is the file, Morogoro, then I'll just select open. So this is a temperature column, this is a humidity, and this is the wind, and again this is sun hours. Okay, so CROPWAT is going to use a Penman Monteith to calculate radiation and ETO, which is reference evapotranspiration. Okay, that is very important. Just remember, so this is my station, which is Morogoro, and again this is the location, and this is altitude of this weather station. Okay, so these are the data that I have. As you can see here at the bottom here, I have average. So this is the average value for this column and this column. So this is the average. So this one is the average ETO, or the average reference evapotranspiration. Okay, that is very important. Now, what can we do here? If you go here at the toolbar here, you have like two options. So if you want to change anything, you can just click options, then you change it from here. So if you want to change the formula, you can change it from here, but for me, I just prefer to leave everything the way it is. Simple as that. So if you want to change, you can just change it from here. And again, the last option that we have here, actually you can even print them, but for me, I just want to click this chart. So this is the chart of reference evapotranspiration in my area. As you can see here, so the highest value is in October and November, and of course in December we have the highest values. Okay, the lowest value is in June. Okay, in June. So this is reference evapotranspiration or ETO. Okay, so that is it. So this is ETO of course in millimeters per day. Let me close. Okay, now that is climatic data. Remember, two options. If you have local data, that is very good. You just you just take them and type them in here. If you don't have, you can use the approach that I used, which is CLIMWAT. Okay. Okay, so from here, let me select rainfall. Now this is climate, now rainfall. Just click rain from here. Then, so this is the window that is going to show up. So we have several options here. So this is the monthly column, and this is rainfall, and this is effective rainfall. Now this is rainfall, but effective rainfall, now this is the portion or the amount of rainfall that is stored in the soil or root zone, and it is available for plant uses. Okay, that is effective rainfall. Now there are several formulas or several methods that we can use to calculate or to estimate the effective rainfall. Now, as far as CROPWAT is concerned, we have several options. So the first one, let me click this. Now just click here, option. Now the first one here is fixed percentage, okay? And the second one is a dependable rain, which is of course by FAO. And the other one is empirical formula, USDA conservation service. And the last one is by assuming that there is no any contribution of rainfall in your irrigation, which means the effective rainfall is actually 0. Okay, so by starting, let me start with fixed percent. So I just assume that 80%, of course by default here is 80. Now I just assume that 80% of rainfall will be stored in the soil as effective rainfall. Okay, so let me click OK. Let me click OK first. So nothing show up here. Now what we need to do is to import our data. So if you have local or locally available data, you can just type them here. Okay, so let me click here, open. Of course, this was my file. Okay, so for rainfall, this was my file. So let me click this, then click open. Okay, so this is the rainfall. Okay, rainfall. And this is, now let me select, I want to use this one. So, and this is effective rainfall according to fixed percentage. So I just assume that 80% of rainfall will be stored in the soil as effective rainfall. So if you take 80% of this is what you are going to get. 80% of this, actually this is the answer. So this is the first option. So the next option is by using, let's say, USDA. Okay, so before I proceed, here we got 748 millimeters. Okay, so the next option is USDA. Let me again click OK. We get 758. Okay, so this that is USDA, and the next option is by using empirical. Okay, empirical. So this is 748. But then the next method is by using dependable rain, okay, by FAO. So let me click this and see what I have. So by dependable rain method, we just get 514.4. Remember, by using USDA, we got effective rainfall value as 758, which is the highest, and the lowest was actually it is by this formula here, dependable rain, okay, which is 514 millimeter of effective rainfall. Before I proceed even further, let me go back here. There is a paper here. We need to see what they say about. Now this paper was produced to see the impact of effective rainfall on net irrigation water requirement. Of course, the case study was in Ethiopia. Now, to keep the long story short, as you can see here, this is net irrigation water requirement, of course in liters per second. So by using dependable rain, okay, dependable rain, which is this with the lowest value, what these people get is that by using dependable rain, they end up with this amount. So from here, as you can see, 0.4, and by using USDA, they end up only with 0.3. So what what you can learn from this is that by using dependable rain, you will end up with the highest value of net irrigation water requirement. Again, if you go here, this is a dependable rain. Again, this is the highest value compared to USDA method. Again, if we go here again, so the dependable rain, the highest value compared to the rest. Okay, the highest value compared to the rest. Okay, so if we go down here, so let's read their recommendation. Now, according to them, what they are trying to say here is that it is recommended to use dependable rain method in water sufficient area and USDA in water scarce area. So why in water sufficient areas? Because dependable rain, you will always end up with the highest value of net irrigation water requirement compared to the other method, of course, for our case USDA. And what they say here in the USDA in water scarce area. So why water scarce area? Now, water scarce area, these are the area where water is a little bit challenged. Now, you need to design your system in such a way where you will not end up with the highest value of net irrigation water requirement. So according to their paper, they recommend USDA in water scarce areas. Okay, so for me, I'll just stick with dependable rainfall. Okay, let me go back here. So this is our method. Now, before we proceed, let me check again on rainfall not considered. Okay, so we just assume that effective rainfall is 0. As you can see here, effective rainfall is 0. Actually, this method tried to negate the contribution of rainfall in your irrigation. So that's but for me, I will stick with a dependable rain, just like this. Now, let me go back here and check the charts. So as you can see here, this is our chart. Now, the purple one is rainfall, and the gray, I think this is gray, is effective rainfall. Now, as you can see here, we have these values here. So at this area, we have almost 0 effective rainfall. Okay, so these areas, so even if we go back here, you can see these areas we have 0. So from here, you can even print. That's all up to you. Okay, so the next part is crop. So from climate, rainfall, then let's go to crop. Okay, so we have our climatic data, we have rainfall data, okay, long-term rainfall data. Now we need to introduce our crop. Now for this scheme, let me assume that we are going to use, again, from here, you can even insert your data from here, but if you don't have, again, you can use this available data. So for me, I will just go with tomato. Yeah, tomato, I think this one. You can choose it from here, any crop that you want. So for me, I'll just go with tomato, just like this, then click open. Okay, so these are the data, the tomato data from FAO database, okay, FAO database. Okay, so what can we learn from here? Now let me maximize so as you can see clearly. So this is the name, of course, that is tomato, and planting date, it just assume 3rd of May, and the harvest date is this one. Okay, so this is the KC value. Of course, this is the initial stage with KC value of 0.6, and the mid season with KC value of 1.15, and the late stage or the late season of 0.18 as KC value. Again, the stage is initial. Of course, the number of days here are 30 days, so you can edit if you want. So if there is nothing, so for me, I just maintain the way they are. So the total duration or the total cropping duration is 145 days. Again, the next thing here is rooting depth. Okay, so this is the rooting depth. So for at the initial stage, we have 0.25. Remember, this is in meter. And again, from mid-season, we have the highest value of rooting depth, which is 1, of course, 1 meter. Okay, so then the next data is critical depression, of course, which is in fraction. So these are the value. And the other one is yield response factor. So as you can see here at the initial stage, the yield response factor is 0.5, which is the lowest, of course. And at the development stage, the yield response factor is 0.6. So here we have the maximum value. What does this mean? So at the mid-season, any reduced amount of water is going to have the highest negative impact on your yield. This is the stage where your crop need the full irrigation. Okay, so the full irrigation. Otherwise, you are going to have negative impacts on the yield. Okay, so the next option is CROPWAT 8. Of course, it is optional, 0.6. This is optional, so there is nothing you can change. So this is a crop data. Again, if you have it, you can insert them manually, but if you don't have, you can use the available CROPWAT data, of course, on CROPWAT database, just like that. Okay, so after crops, what next is soil. Okay, so you can just click soil. This window will pop up again. So from climate, rainfall, crops, what we need again is soil. Now from here, so soil data. So these are the data that you need to derive or you need to acquire through experiment or from the lab report. But if you don't have, you can use the available data. So from here, I'm just going to click open, and I will assume my field has a sand loam. Remember, these are the data that you need to measure. You need to take measurement from the field. So for me, I'll just assume sandy loam, just like that. Then I'll just open. Now let me maximize, just like that. Okay, so this is the data. So soil name sandy loam. Of course, this is the soil name, and another data here, which is total available soil moisture. Of course, this is the difference between field capacity and the wilting point, which again is 140 millimeter per meter. Maximum infiltration rate, which is 30 millimeters per day, and maximum rooting depth, which is 900 centimeters. Again, we have initial soil moisture depletion, of course, as a percentage of total available moisture, which for my case, I'll just maintain as 0. And the last value, which is initial available moisture, which is this one. Of course, this one is calculated. So there is nothing here we can have. Of course, you can print it. So for me, this is the soil data. Again, as I said, if you can, just go and take field measurements and extract this value and use them in here. But if you don't have, you can use the available data, just like we did. Now the next point here is crop water requirement. Now from here, from soil, let me click crop water requirement. Now from here, there is nothing else we need to insert. Everything here is calculated. Okay, so everything here is calculated by using climate data, by using rainfall data, by using crop, by using soil data. So this is what we have. Okay, so from here, what we need to learn is that the first thing here is ETO station. Of course, from this tab here, this ETO station is in Morogoro. Again, rainfall data station is this. And again, our crop name is this one. Of course, tomato from this, which is tomato. And again, our planting date, we just assume it is this date. Okay. Now, the first column here is month. The second column is decade. And now decade is a period of 10 days. Okay. So every month has 3 decades. Okay. So from 1st of May all the way to 10th of May, that is the first decade. Again, from 11 to 20, that is again the second decade. And from 21 or from 20 to 31, that is again the third decade. So every month has 3 decades. Now, the next column here is stage. Of course, this is the initial stage, development stage, mid stage, and late stage. Of course, this is the data derived from crop data here. Again, the next one here is KC. Of course, this is a crop coefficient. As you can see, at the initial stage, we have this coefficient. At the development stage, this one, late stage, and so on and so on. Now, the other one is ETC. Now, ETC is the product of KC times ETO. So ETO, or reference evapotranspiration, times this KC factor here, you will end up with ETC. Now this is ETC in millimeters per day. Okay, so millimeters per day, and again we have this is ETC, or crop evapotranspiration per decade, millimeters per decade. Okay, so you just take this one times, so from 3 all the way to 10, this is times 7, so this times 7, and this times 10, this times, I think, times 11. So you just take the number of days within the decade times this value here. So this is ETC in millimeters per decade. Again, we have this effective rainfall, which is in millimeters per decade, and again we have the irrigation requirement, which is this one, of course, in millimeters per decade again. Now at the bottom here we have the summation. So this is irrigation requirement, summation of irrigation requirement, which is 399.1 millimeters per decade. Okay, so the next tab here is schedule. Okay, schedule. Of course, here we don't have. Now from here, I don't think we now let me go back here from in crop water requirement. You can even click charts to see what you have. Now this is irrigation requirement. So from here, as you can see here, this is month May. Of course, this is a period, decade 1, 2, 3, and again this is month June, of course, with the decades, month July with its decades, and so on and so on. So these are the graphical presentation of our irrigation requirements. So from here you can even introduce ETC. So this is our ETC. As you can see here, this green line, which represent our crop evapotranspiration. Now that is it. Now let me go back to irrigation schedule. Okay, so what do we have here? Again, there are several options here that we can take. So the first one here, what you can do is to click this option. So if you have anything that you want to change, you can change it from here. Now let me click here, options. Okay, so you can just decide when do you want to irrigate. So I want to irrigate at critical depletion level. Okay, so as you can see here, irrigate at 100 critical depletion, or you can even choose the other approaches from here. So for me, I'll just maintain this one, irrigate at 100% of critical depletion. And again, we have irrigation application. So we want to apply water to refill soil at the field capacity. Again, you can change the methodology or approach from here. For me, I just want to irrigate to maintain root zone at field capacity, just like that. So refill soil refill soil moisture content to 100% of field capacity. Again, the next important parameter here is irrigation efficiency. Now it depends on what irrigation method that you are using. If you are using surface irrigation, for example canal, I expect you to have here the lowest values, let's say from 40 to 50. So you can even put here 40 if you are using canal. Of course, it depends on your irrigation method that you want to use. For me, I just assume that I'm using drip irrigation method. So from here, I'll just maintain 90. So if you have anything else you can change it from here. So from here, I can just click OK, just like that. So ETO station again is this one, rainfall station this one, crop name this, and soil name this one. So planting date and harvesting date. Yield reduction factor, just maintain 0, no problem. So table format, I want to use this one. You can even use this. So for me, I'll just use this. So timing. So from here, all these settings here going to appear here. So timing, irrigate at critical depletion. Application, refill to field capacity. Field efficiency, of course, I just chose 90%. Okay, so from here, as you can see here, we have stage, which is development stage. We have mid stage and all that, and all those stuffs. KS factor. We have ETA, depletion level, net irrigation. So if you take net irrigation divided by 0.9, okay, 0.9, you are going to get this gross irrigation, which is 43. Now at the development stage, we need 0.1 liters per second per hectare. Okay, so for me, I just assume drip irrigation because of this highest value of field efficiency. We only require this amount of water, which is 0.1 liters per second per hectare. This is development stage. At the mid stage, of course, this is the stage where, so this is stage here where we require a full irrigation or the highest amount of water. Okay, so this is the mid season. So from here, as you can see here, we need 0.3 and the highest being 0.46 liters per hectare. So that is scheduling. Of course, you can just go and even look to this data here. So for me, that is what I have. Now let me click on option. We are done. Let me click charts. This is what we have. Okay, again, this one is total available moisture, and this is depletion. So as you can see here, you can even close just like that. So I'll just maintain here. Now the next step here, let me go to crop pattern. Okay, so at this point we just assume that we have only one crop, which was tomato. Now what if you have multiple crops? Okay, you have more than one crop. Let's say you have tomato, you have cabbage, you have maize, you have, and all those stuffs. Now how can you handle, or how are you going to handle such a situation? Now this is the point where crop pattern come into play. Now let me click this and show you something. Now crop pattern. Now before we proceed, we all know that a crop pattern, we have like 3 crop patterns. The first one being the mixed crop pattern, intercropping pattern, and the last one being the rotation crop pattern. Now from here, the first thing that we need to do is to give it a name. Let me call it pattern 1. You can give it any name that you prefer. So from here, I just am supposed to insert my crop. So from here, let me select crop file. Okay, so my first crop here is potato. So let me select potato, and my next crop here, I'll just assume that I plant cabbage. Of course, this is just an example. Okay, this is just an example. Let me assume that I have cabbage, and the next crop, let me assume that I have which crop? Beans. Let me, beans. So let's select beans. And the other one, let me select the last one. Let me select, maize. Okay, maize. So in my scheme, these are the crops that I have: potato, cabbage, beans, and maize. So 4 crops. And again, from here we have a planting date and harvesting date, Now the next important parameter that we need to insert is area. So in my area or in my farm, which percent is occupied with potato? Okay, so let me assume 40% of my area or of my farm is occupied with potato. The next is cabbage. So let me assume that 20% of my farm is occupied with cabbage. And again, so remain what? So 6. Okay, so here again, let me put here 30. And maize, only 10% of my land is occupied with maize. So this plus this plus this, so we have 40 plus this is 60, 90. Of course, this is 10. The next point here, we need to give it a name. Let me give it again a name. Pattern 1, just like that. So this is our scheme with 4 crops. Okay, both of them are planted on the same day. So you can even change the days here, or the date, or planting date. You can even change the planting date from here. For me, I just assume that both of them are planted on the same date. You can even change, yes, I've said. Remember, we have 3 cropping patterns, so you can change it the way you want from here. Okay, so the next thing here is to actually see the scheme results. So from here, let me click scheme. Okay, this is what I have. Now let us go one by one. Let us go through it one by one. As you can see here, we have a ETO station, which is this one, and of course rainfall station, which is this one, and cropping pattern, which is a pattern name that we gave. Now from here, this is our crop. This is potato, cabbage. this is green beans, and of course this is maize. Okay, so as you can see here, January up to April, we have nothing was cultivated. Now from May, this is the point where our crops was cultivated. So from here, yeah, as you can see here, planting date is in May, is 3rd of May. So this, so from here, we have both of our crops were planted. So from May, June, we have our scheme was occupied, as you can see here. So if you go down here, you can see percent area, irrigated area is on May was 100. So 100% of our scheme was irrigated, because at this day all of our crops was planted. And again on June, 100% of our scheme is supposed to be irrigated. Again on July, 100% of it will be irrigated. So at August, green beans will be harvested. So only 70% will be irrigated, because green bean will be harvested. Okay, so that is it. And again on September, only 70% of our field will be irrigated, and on October, only 20% of it will be irrigated. So at this month, we expect to have only cabbage. Okay, only cabbage. So the rest will be harvested already. So only cabbage will be irrigated, which means only 20% of our area will be irrigated. On November, our scheme is free all the way to January. So remember, I just assume here my crop was planted on the same date. You can even change the date from here. Now, one thing that we need to learn here is that this is net irrigation, net scheme irrigation requirement, of course in liters per second per hour or in millimeters per day. As you can see here, the values are quite different. So you can see here at this stage we have only 0.28, while here we have 0.4. Okay, so this is the net scheme irrigation, and this is irrigation requirement for the actual area. So what we are going to concentrate with is this bottom line here. As you can see here, at month May, we have only 0.06 as a irrigation requirement for our scheme. Okay, so this is the month where our crops are in initial stage. And again, on month June, we have 0.9 liters per second per hectare. Of course, liters per second per hectare. Again, in month July, we have 0.38, and month August, we have 0.4. Okay, so 0.4. Remember, at this stage, we have 100% of crop of our farm is expected to be cultivated. And again, on month August, we have 70% of our farm again expected to be cultivated, but here we have 0.4. So this is a development stage, if I am not mistaken. So a lot of water is required here, even though we have only 70%. Again, here on September we have 70%, but irrigation requirement here is 0.2. And again, this area here on October we have 0.22. So this is your irrigation requirement. So the irrigation requirement for the actual area. Okay, so this is liters per second per hectare. So you can just do simple calculation here to get the amount in liters per second. So that is it. Now the next thing that we need to do is to print. So you need to make sure that you print all of your data from here. Okay, so from here, let me select preview. So these are the data that you have. So you can click here next. Okay, it's like 5 pages. You can click here. So all of your data will be printed right here. But one thing here, I think we are missing. Let me see from here. Let me select charts, and again from here select charts, and again crop water, select charts, schedule, select charts. Now let me go back here again, select print, select all, then click preview. So as you can see here, now we have 6 pages, I think. So these are your charts, which is very beautiful report. As you can see, you have your data, your charts from here. Okay, your data, again your charts. So you can just print and take a look at it just like that. Now lastly guys, I would like to say that this is just a model, okay, and anyone can run a model, but very few people can interpret what the model is actually telling you. Okay? So the most important part is not running the model, but is to interpret what your model is telling you. That being said, I prepared a very good playlist for 8.0 tutorials, of course, are related to pumping water supply projects by using 8.0. I'll make sure that I include the link to that playlist either on the left or the right of this screen. So I really encourage you to go and watch that playlist, and not just that, you can even go to our channel and watch more video tutorials because they are very informative. Again guys, thank you. If you made up to this point, thanks a lot, and I'll see you in the next video.